Welcome back to Tech Days Online, the DevOps Day. With me, I'm very pleased to introduce the only man that talks faster than Andrew Fryer. This is Boris Devouche, newly employed at Microsoft, Mr. Open Source, and he's going to talk to us for the next 45 minutes about open source and DevOps. Boris, over to you.
Thank you very much. So thank you very much, everyone, for joining today. And today, effectively, an interesting subject, a subject that we're not used to see within Microsoft. Open source on Azure, and particularly implementing DevOps process and methodology on Azure. So how does that look like? The first thing to understand is effectively is our Microsoft open source momentum is currently alive. So we have made various announcements, and Microsoft has opened us enormously to go effectively across the other side and allow customers not only to run the well-known and trusted Microsoft technology in Azure, but as well to run anything that is coming in terms of innovation, open source, other framework, and effectively making sure those can interact across solutions, particularly when people are going to the cloud and trying to export effectively infrastructure outside of the company. So that open source momentum you can see on that slide is reflected by various announcements with OpenSource.net. Satya came obviously out there and spoke to the people and say, hey, we love Linux. Actually, what he was doing is revealing to the world that about back in the day, 20% of every single VM in Azure worldwide were powered by Linux. So it was a very interesting statement from Satya to come out with this. Then you can see some various quotes, obviously, from the press reflecting effectively that advance, reflecting that openness, that change, that new Microsoft effectively kicking in. So this is important to understand the strategy. But now let me show you, I mean, I'm sure you follow this, but let me show you a few of the announcements that we made recently. And I know people are very, very surprised looking at it. So the first thing is, of course, SQL Server. We have announced that SQL Server will be effectively migrated and ported running on Linux host in Azure. And this will be done around mid-2017. We have a very active project for it. There's a page that you may welcome to look at, microsoft.com/SQL on Linux, in a single word lowercase, that will redirect you to the right page. And on this, you can effectively connect to actually request some news and some information, but you could as well just request to be potentially added to the preview. So I don't want people to get excited over the video, and I'm going to tell you the reality. The day we launch SQL on Linux, we receive more than 9,000 requests within the next 2 hours to be part, obviously, of the preview. So you can imagine this is already filling our case of preview currently. So unfortunately, I can't promise anything for preview right now, but at least you'll be able to register your email and receive update notification on other project advance. Red Hat, very important one. So Red Hat Enterprise Linux was not a certified operating system on Azure. It is now. It is now since November. And effectively, what we've been doing is having not only just an agreement with Red Hat to certify, but as well a much broader announcement of various different interactions. So essentially, we're going to have .NET supported on top of Red Hat Enterprise Linux for customers wanting to, again, mix the different technology across. We're going to support their PaaS platform, and at the same time, of course, Red Hat supports all of the product of Microsoft on site. So it's a nice exchange and nice collaboration there. HD Insights, so as you know, this was our Hadoop on-demand platform that we had on Azure. This was exclusively running on Windows. So we have now made it available on Linux host. So by default, when you go and provision your PaaS in your Azure interface, you can say, hey, give me HD Insight, but actually I want it on top of Linux host instead of Windows host. And this has been available. And what's interesting is a lot of people dealing with Hadoop on demand are data scientists who are very interested to have a low-level access to the shell and be able to manipulate their data. So as a result, not really because it's on Linux, but as a result of the accessibility, we've seen really a very big hike in the consumption of HD Insight. Eclipse, we joined the Eclipse Foundation. So Eclipse obviously is one of the biggest IDE for the Java world, but it does other languages like Java too. But we have now launched the foundation, which means Windows and Microsoft are an active part of it. And obviously .NET will be added to the list of language supporting Eclipse. So the idea there again is to enable a developer to be able to deal with different language, different technology from the same single host. The Windows subsystem for Linux, I think this is the newest announcement. That's the one.
It's certainly the one that's got me most excited. I spent a lot of time playing that.
Have you?
Days,
it's
really great.
It's interesting. My machine is running it as well. And I think what's interesting there is effectively to enable suddenly a little bit of Linux tooling, a little bit of command line to be able to do various things right and left. So this has been a request coming mainly from the developer community saying, hey, I use Cygwin, I use Putty, I use those tools that are not falsely endorsed. It'd be nice to have something endorsed. So we have done that, and you can see on that slide a little bit of a demo there. So essentially, you just launch your command line interface on Windows. You type bash, you type enter, and this, well, I mean, no, that has been really ameliorated there. This is much faster. It will obviously do a little bit of install for you. You need a build of Windows 10 that is higher than 1314 in order to get effectively this. But this is a new, what we call the Windows subsystem for Linux, which is available and get you a full Linux shell available in Windows, so enabling you to effectively interact with the other part. So a lot more announcements have been made. So another thing interesting that I wanted to say today is that we have now a certification for Azure, for Linux on Azure. So all those that work, that's a mixed certification essentially between the Azure Foundation and a certification course that has been put by partnership by the Linux Foundation. So once you pass the two elements, then you become officially Linux certified on Azure. So very interesting. Our Microsoft employees, so Vim has joined us from Oracle. So Vim is actually Mr. Linux Oracle, been working there for 20 years and more responsible of the major change of Oracle towards open source software. So is in Corp and will be essentially heading or head of full vision into Linux. And Ross Gardler, obviously, which maybe you heard of, is a Brit, but he lives in the UK now, in the America now. And Ross is actually president of the Apache Software Foundation, and accessory as well is the lead behind our Azure Compute Service, Azure Container Service. So very interesting. You can see all kind of data and stats there. 60% of our marketplace are based on Linux, so people who will deploy a solution from the marketplace will deploy Linux pretty much without knowing it. And 1 out of 3 VM now, I can reveal, is effectively now on Azure running Linux. So this is quite extraordinary in a race. We're very excited to see this, and I think it's important to see that there is a demand and that the customer are very happy to look at it. So I think this you've seen several times, and I think we discussed that slide several times. I'm sure it's absolutely not new for anybody out there. But I want to repeat really that idea that not only we're enabling technology, but we're making them come first from an area that we call ecosystem provided, you see on the right there. And that area will be an area where we'll have community support images, where we'll have community vendors who will support the image, but Microsoft itself won't endorse it from a support point of view. We let you run it. We just make sure we validate it and make sure that it works, but we won't provide direct support on it. We rely on the community. But what's interesting is as we built our ecosystem, as we're getting closer to the people across there, we effectively then move them to integrated where our own support can relay the calls there. And you can see this obviously. So for example, that slide shows you Xamarin, which we have made an acquisition of. Yeah. And obviously now Xamarin is completely to the left inside of the slide.
And I noticed just this morning in my blog feed that Jenkins now has got a much closer relationship with Azure as of literally just today. So
absolutely, you're very well informed.
Move forwards on this.
Yeah, you're completely right, and I think that Jenkins will come exactly in due time for that discussion, particularly around DevOps, and you're going to see the foundation. So, moving forward, I think what's very important is to understand what is DevOps, and you will find so many vendors, so many definitions of DevOps in different areas, in different, depending which area you deal, which software you have, which product you have. The reality, and what I want to do is to flatten a lot of that messaging across it, and say essentially DevOps is around 3 things. It's the people, it's your process, and it's your product that get all transformed. But the most important thing you can see is actually on that slide, is that concentric, is that circle, is that revolution. DevOps is something that once you start, you do not stop. DevOps is actually, you could do DevOps in your company simply by keeping the same development model, but increasing the rate of release of software, release of publication, and etc. The whole idea in DevOps is you release often, you release fast, and therefore you get a lot more learning and a lot more chances to correct your software. And what's very interesting is in the past, deployment used to take hours, putting things together. So obviously when you had a new version of a software, you had to open a maintenance window, you had to stop people or provide maybe a side on the side for people to use. And then of course on the other side, you had to patch your product as fast as possible, test it was okay, and bring it back of course in line of use and in production. Well, nowadays with systems such as cloud, virtualization, but particularly containers, we are able to have absolutely flash deployment. I mean, I'm talking, I'd replace a container on my Linux machine in Azure in what? In something like half a second. So it's really right. So the whole idea and what we're going to expose there through DevOps is really not only putting DevOps in place, but having a further vision of my services, of my process, and how they're going to react, and make sure that the DevOps process will give them an advantage, obviously, on running them.
And we've heard already in sessions today about things like Azure Stack, containers on Windows, how release management, the Visual Studio release management can help with that, but also how things like Chef, Puppet, Octopus Deploy that aren't out of the Microsoft stable can all be used as part of the process with Azure as well.
Absolutely, and we'll discuss that a little bit later, showing out the different DevOps tools that we make available on Azure, but that's a very good point. And I think just to accentuate your point, it's important to say that DevOps doesn't really have a stack that is appropriate. DevOps changes so fast, and new tools are coming so fast in a picture that by the time you will put a slide, you will have already 2 new tools. So DevOps is really about the choice of your engineers, of your people, or what they get used to, or what they learn, or what they find that is maybe simplifying their task. But it's really within an idea of repeating that fast build and release system, doing that testing, developing, and as well realizing that the plumbing around your DevOps infrastructure is the most important. So before you can even start doing DevOps, you need to actually have an infrastructure, have a plumbing, have a deployment model, have a release model. All those things need to be organized. And then the testing, when you see develop and test there as number 2, the testing within the product at deployment or build time becomes even more important. So I'll argue that a lot of your code in DevOps will go against the testing and the release management of the product itself rather than the product itself. Yep. So before you can even code on anything, there's effectively a fair bit of work to be put into standing up my testing infrastructure, my model, the release, and etc. So good point, thanks. So this, I think I've just mentioned it, but what is DevOps? And I want to mention that out there you will see the tagline that is, of course, developer and operation working together in a new role, in a single role, and etc. I'm going to take a tangent to this. I'm going to tell you this is a very good marketing vision of it, and this is a very good explanation on how it comes to us. But the way to implement it into your company is really about understanding infrastructure as code. And what I mean by infrastructure as code is, in the past, you used to have somebody that order a server, then go and pick it up in a warehouse and bring it in the data center, and then unracks it, and then put it out and put the network cable, and then he passes it to the provisioning team, who passes it to the security team, etc. So very vast, long deployment model. Nowadays, guess what? With cloud, deploying a server, it's a single API request. A single API request will actually proceed all of those operations. So think about deploying infrastructure nowadays as code. You don't need those guys who goes everywhere and they set up your data center. You're running in the cloud and essentially deploying my first step infrastructure, my DNS infrastructure, my base OS infrastructure, my minimum standard operating environment, for example. This is just code, and this is just API requests. So 2 things for me that I will redefine DevOps here is treat infrastructure as code, and effectively apply that CI/CD, continuous integration, continuous deployment model we're going to see in a minute, but as well automate and increase the determinism and bring idempotency into operation. So I know it's a crazy word, idempotency, but essentially to translate it, idempotency means I can rerun the same command 10 times. It will do it the first time, and the 9 other time will simply do nothing because the system is idempotent. He understands the status. A system non-independent will run the first time and bring me 9 errors saying already done. That's typically of a system. So you want to have idempotency. Why? Because when you build your platform of DevOps and you want to add, a little bit there, you want to change a little bit there, particularly with ARM and Azure Resource Manager and Template, you'll be able just to add a little bit in there and just simply rerun your deployment. And only the difference of that deployment will go ahead and be done.
I think that the key thing for me on this is that because you've declared your infrastructure as part of your project, you know that the developers, the testers, the QA guys are creating exactly the same platform to run your code. So it doesn't matter that, I haven't patched this box and I get different test results. It's the same every time. And that consistency is really key, isn't it, Boris?
Exactly correct. So I think you're right. A consistency, determinism, and determinism at the deployment model is very important. And we'll add a little bit on that when we bring the containers in it. So CI/CD, so continuous integration, continuous deployment, continuous delivery, is a very interesting subject. So what I put there, I've listed some some really element of that strategy. So if you look at continuous integration, it means pretty much all the bullet points you find on the left, continuous delivery, all the bullet points on the right. And they're not here to be read or to be applied on the letter, but it's here for yourself to say to ask yourself to look at your infrastructure to say, am I really doing DevOps? Am I applying any kind of methodology there? Well, read one of the sentences and try to apply it to the project when you read. Yeah. So do you automate the build all the time? Do you make it easy for everybody, for example, to get the latest executable? Can everybody see what's happening independently of all the trees and all the development? And these are the very interesting parts there. In delivery, you're going to ask yourself the same question on the right. So again, I put them there as being kind of empiric definitions, but I don't want people to think, oh, I need to do this if I want to do DevOps. No, inspire yourself from it. See how you can take effectively a shortcut within your organization. And sometimes doing DevOps into a development project, it could be simply about adding a couple of tools and increasing the release time and increasing the cycle and putting it into a cycle. You don't forcefully need to start from scratch. You don't need forcefully to change everything. And remember, the more legacy you will have in a development project, the hardest it will be to bring effectively to a pure DevOps vision. So sometimes even just one of those bullet points in an existing project can result in a massive win and massive cost.
Yeah.
So obviously there is a part with Visual Studio, and how do we align? Well, we align exactly the same thing. So now Visual Studio is online, as we know. It has Azure completely built within it and in the middle of it, particularly for the release cycle. And effectively the plan, the whole steps of our DevOps are completely applicable and easy to actually automate and operate within Visual Studio. An additional thing that I will bring there from the open source angle is Visual Studio is now able to deploy directly to a Docker container. So if you were to test your app on containers nowadays, instead of deploying to a host or to a piece of infrastructure in Azure, you could tell Visual Studio, hey, actually deploy to Azure on a Docker container. And this will be spanned on top of a Linux host, on top of Linux containers, and you'll be able effectively to interact. And what I mentioned earlier is the fact that I can deploy that very, very quickly. It's like, it's amazing how much data gets copied on the system that quickly. So
I think we also need to point out that it's not just Windows, is it? You can build now, the build agent for Visual Studio Online and Visual Studio On-Prem runs on Linux. You can do Linux builds as well as Windows builds.
Absolutely correct. So this is really that way. I mean, so I'm saying it with caution because I don't expect suddenly everybody in the open source world to try of Visual Studio. But you're completely right. If you have been dealing with Visual Studio and you see the latest update and the latest product really broadens the horizon of what you can do with an IDE, I fully agree with you. And particularly integrate all those different pieces in a new product. You can even have access to very early products for Visual Studio. So it's very important. I'll mention as well the code editor of Visual Studio, which is a light version that runs natively on Linux and Mac, if you're so inclined to try. Yep. That's very good as well. So this I was keen on speaking about that because you mentioned it, you touched that effectively from the get-go. So this is just a glimpse as well of the small development tools that you will find on Azure, and I think it's important to understand that when you recruit your development people, when you have your dev team, they will grow familiarity with particular tool. It's very hard to change the mind of a developer for any kind of particular focus, etc. So that's why what we decide to do is to have the broadest and try to get the broadest set of ecosystem utilities application findable on Azure. So anybody can find his pleasure there. Anybody can go say, oh, I wish they had that. And actually, I fell myself into the mistake myself. And I mean, I had a customer not long ago asking me, hey, do you have that particular version? And it was something quite obscure, which was a fork of an open source project. I mean, obscure, not that well known, I will say. And right away, I said, no, I do not remember, I do not believe that we have that. And actually, on the back of that discussion, I went to Azure immediately. I went actually to our VM depot, which is our community repository of VM. And I find 12 versions of the project that the customer wanted. So I've answered the email immediately. I say, I'm very sorry, I stand corrected. Here's the link, and effectively it's available. So VM depot, I should mention, is actually our free community repository within Azure. And you'll find what, at the moment, I think it's 3,500 images in it. There's so many images, there's always something. Of course, support there, you will need to engage community or the particular vendor. But if you know what you're doing and you like the tool, it's a very easy place, again, to find your builds ready for Azure. So coming back on those DevOps tools on Azure, so they're covering a bit everything. They go from monitoring and diagnostic, config customization. So I don't like that word, but that's an easier word for everybody to understand. In the IT world, in a specialist word, they actually call CMDB, which stands for Configuration Management Database. Mm-hmm. And what they are is usually these are essentially essentially you have two elements, client server. You install one on the client, you have a set of recipe of rules that the client enforce and reports back to the server, obviously. So the first one who did that were the guys like Puppet, Chef, the other one very well known. DSC extension in PowerShell does direct state configuration that is very, very similar for Windows machine.
And Linux as well.
And it's available for Linux as well. And Docker, obviously. So Docker is different, that's containerization, but because it comes with a whole set of customization around it, it has been put in there. And Ansible and SaltStack, I will say, are the last two kids on the block in this kind of a CMDB land. Ansible being bought by Red Hat very recently. So strong over Red Hat agreement, Ansible will be a tool that will be, of course, fully validated in Azure. Release management is important to pass. So you mentioned Octopus Deploy. So Octopus Deploy is very interesting, and we'll find it in mixed environments, in people who have effectively a side of DevOps with Windows app, .NET app, and as well some open source elements. So that's usually the choice there. Jenkins is actually a build server, as you mentioned before. And as you mentioned, we have effectively stronger agreements now. Actually, the agreement started with engineering to make Jenkins work more optimally into Azure. But Jenkins, if you never heard of it, is actually a server that will collect effectively the different repository of all the developer, and will follow some rules to actually go and build the product. Then it will build, it will launch it, it will test it, it will run various tests on it, and email your developer back in the morning. So it's a very good way if you look at automation at DevOps to, for example, every night I want to build. The moment your last developer check out, Jenkins will move into action, collect every repository, start to assemble, build, and report failure testing, etc. So Jenkins, there's as well another one called Hudson that used to be known from the Java world as well. There's various different solutions, and Jenkins is the biggest, is the most used effectively. And there's, of course, Visual Studio Release Management that we mentioned before. So another thing I want to mention in the provisioning is all the CLI that you see there, and I want to mention them very quickly. So Azure CLI is our own command line tool. We distribute this. This is installable on Linux, on Mac very quickly, and you can do a lot of things. You can actually deal with template with it, or you deal directly with the resource management and you launch a VM, create a network, etc. Knife is something not very well known, but it comes from Chef. So I know it's, open source is funny, and we like to play on the words there, but the company was originally coming from Xcode, but now it's chef.io, and Chef, obviously, the tool of a chef is a knife, yeah? And the knife applies recipes. I mean, we can't go on forever, but you got the idea, so it's all around cooking, but Knife is their command line, and Knife Azure is effectively a command line utility for Azure that will enforce Chef recipe into it. Puppet CLI, we just mentioned Puppet, part of it. So Vagrant is something I want to spend a little bit more time. Vagrant is like, I don't want to be too technical explaining it. It's basically ultra quick virtualization on my local machine, right? So Vagrant allows me to have a very quick image of a host of an image.
Yeah, so in our project we can say, okay, you know what, guys, we need a domain controller and SQL server in here. Vagrant lets us define that environment, check it into source code, and all the devs can do it. Importantly, Vagrant, again, supports Hyper-V on the desktop and on the server as well as Azure.
So there's a very good cross agreement there, I agree. Vagrant has been used as well in the Linux and Mac world for ages too. So this is a very good tool that crosses everything. The last two things I mentioned are libcloud and jcloud, and these are open cloud libraries. What are they there? They're there effectively to enable you to code across a library to have a variety of different cloud or target a particular cloud. And I want to mention that not for long, our excellent partner ElastaCloud in the UK has actually provided some code towards libcloud to get a proper Azure compute driver in libcloud. So essentially you could look at it through this way. That will be another way to interact with Azure outside of those tools. But really want to mention that on the strategy point of view, we want to make Azure available through the web UI, through the interfaces, through the API, and we want to make sure that basically everybody can consume Azure from any client and any interfaces. Make sense?
Absolutely.
Fantastic. So the Microsoft ecosystem on DevOps, and these are recent slides, as you can see, but what's very interesting on this is effectively are we building that from Team Foundation Server, Visual Studio Online that you mentioned, and effectively moving on into Test Manager, for example, so develop, build, test, deploy, monitor, and learn. And again, those 4 steps on DevOps were mentioned. And as you see on top, maybe it's not as well expressed as on my previous slide, but that circle. The most important part of anything you could do in DevOps is to make sure the project is continual. Yeah, the moment you do stop and you restart, well, this becomes waterfall, this becomes staircase, no matter you want to call it, which kind of project it is. But DevOps is really that idea of, even if you change the code, even if you change the project, it doesn't matter. You still stick to your release cycle. You still stick to your monitoring and learning all the time. So this is coming from and you can see really the path, and now we can work with PowerShell, Azure Resource Management, the command line, and etc. And you can see as well a very similar kind of path going with other open source products. Some of them we mentioned, some of them we'll touch on there. And you can see that all the tools are adding on. So for example, you have Travis CLI, very, very popular tool for DevOps on the OSS area. This is as well supported in Azure. It's not there, but I just want to make sure people don't. If you don't see it there, it doesn't mean it's not supported. Yeah, most of the things are supported. This is just an example. And then you have from a developer workstation that will post this code using Codeplex in GitHub, for example. From there, we'll have Gradle that will assemble it, Grunt that will do some pre-testing, Jenkins and Hudson to do the build, and effectively do the test again with Gradle and Grunt, as I mentioned. And then you go back, what else we haven't seen? So Vagrant, we've seen Hudson, I mentioned it before, Jenkins, Grunt, Gradle, Chef and Puppet arrive there because they're in configuration. So when you're going to deploy, you want those tools to come in, kick in, and do the specific of your environment. And then monitor. So Nagios and Zabbix. So Nagios is typically completely open source monitoring system, completely free. It just puts some probes on your system and comes back to you. Zabbix will be a commercial version of Nagios with a little bit bells and whistles and some particular focus around cloud monitoring too. So this will as well monitor services in your cloud, for example, to make sure they're still on track. So another big thing that we haven't talked about, and that's really that needs to take its part into what time we have left, is really containerization and containers. So containers are coming very strongly. The first thing that I'll mention to everybody around containers is around that is, no, they're not a replacement for virtualization at this stage. They might be positioning there, but what we're seeing from our customer is they're being used mainly in development because they're ultra fast to roll, very agile, very easy to roll out. But in production at the moment, I think people are not trusting yet 100% the container framework to move away from their hypervisors. So we're seeing effectively in customer development on containers, deployment on hypervisors at this stage, and we hope things are going to evolve. When it comes to Docker, so what is Docker? Docker is a company that has really popularized the containerization service. They start from Linux containers. They're doing pretty much everything now. They define an API, they define a command line, they define some tools, they define some marketplace, and essentially they make it very easy for people to use containers. Where I don't think they've invented a lot of that technology, but they put it together very nicely, and people have embraced Docker very strongly. As you can see on that slide, just that simple command line there in the middle is all what you need to actually deploy a host running Docker and running containerization in Azure. So wow. that's fully integrated. We have made as well a very good partnership with Docker, and we have made some community declaration there where we say we're not going to change the API, we're going to respect effectively the ecosystem to make sure that Azure and Windows, which is not so natural to containers now, become effectively prime candidate to Docker. So Windows containers, as you mentioned, Linux containers, and all this, of course, assembled through Docker. So if you will be running Docker like that, you'll be running effectively a host in Azure, infrastructure as a service, and Docker on top. But of course, there's always the option to do this as a platform as a service.
Yeah, the Azure Container Service, of course, is available, and yeah, I think that's a really great way that I don't have to manage the servers I'm going to put my containers on.
Exactly correct. I mean, you want to deploy a container, you want to deal on container, but you don't forcefully want to do, as you said, deploy the whole plumbing and the whole infrastructure of my containers and where they're going to host, and do I have capacity on the host, and how big is the container? No, you want that. So effectively, that's where Azure Container Service comes in. So the first thing I want to mention is first our commitment to the Docker community. And we have made that strong commitment. And I know, again, unusual for Microsoft across the open source community to make those commitments, but very important that we did, because this really shows that we invest seriously into that community. We have as well integrated the Docker Hub, which is their marketplace, into our own marketplace. So if you go essentially in Azure, if you say, hey, deploy new containers, containerized app, you will have there a glimpse of the Docker Hub integrated in the Azure Marketplace. So we made effectively the promises to align with the Open Orchestration API, with the Docker API, and make sure effectively that we have one of the best Docker and container support in there. So the Azure Container Services we mentioned, so this is very interesting. And what we're looking at now, we're looking at another company called Mesosphere and Mesos. And Mesos has essentially released Mesosphere first as an open source model. And this was a full containerization service management. So this is, think about it, about the infrastructure that's going to make a container bigger, stronger, weaker, close it, pause it, etc., etc. So essentially managing my containers. And this is working on the side with the whole ecosystem that you'll find normally on Docker, so which is things such as Marathon, Kronos, and Swarm. If you've never heard of it, I don't want to bore you. If you're interested, Bing those words, and you'll find actually a lot of information there. As they apply to Azure and Azure Stack, and they're doing Linux and Windows Server containers, so that's really the assembly of the service. And what I want to mention about containerization that maybe is not very well known to you guys is really the idea that containerization save a lot of my workloads, save a lot of my disk space, and really help me to organize things differently. So if you look on that slide there on the left, you have the classic hypervisor virtualization model where you have a server, a host OS, an hypervisor, and then you have all of your guests, and then you have application and binaries and libraries on top. Now, as you can see, the first two columns are exactly similar. But because of the technology of hypervisors, I'm going to have to replicate them. So I'm going to have to use twice the storage despite being the exact same clone, same binary, same application, and then, of course, separate them. Now, if you look on the right in a container, I'm going to have my server, my host OS, and then Docker engine, as we mentioned. And then, of course, now I have the ability to run all my app into containers, but I could share some of the binaries and libraries. So therefore, my container will be smaller and more agile. Or I could, of course, include them and put them full within the package to have something more like a gold image, a bit more big and not as fluent, not as easy to manage, but at the same time giving me a really fixed deterministic functionality. So that's what you'll do in a classic lift and shift, for example. You'll take a system, you'll port it, you'll package everything within a container to make sure it's OK. Then in further iteration, you may export and put the binaries and library aside to make it trimmer, lighter, and easier to manage. But the first step will be effectively to combine that. So containers will give us that flexibility that you won't have in hypervisors.
So right now, containers are a good choice if I want high density and I want to deploy quickly and I'm doing lots and lots of deploys often and frequently. I might stick to virtual machines if I need the forced separation that a crash on one can't bring down the others, but I pay the price in extra space.
Yeah, that's absolutely a very good model. I will say as well the additional advantages that you'll have on the containerization is the ability when you do a lot of things that are similar. So when you run 10 machines of the exact same VM on top of a host, rather than replicating, containers are very good at this, on sharing that resource effectively. But no, you got it absolutely spot on. So I don't want it to be a definitive statement. This is right now, fully agree. It's important to understand that first, companies such as Intel and AMD at the processor level are implementing future stuff to make containers slightly more robust and more resistant to separation and that level. So potentially they could be solution of the future. And it's important as well to realize that because containers are quite hot and new, if you look back in 2009, 2010, virtualization just came out, but it got really adopted, 4 or 5 years later. So we are at that stage with containerization where they need to have a little bit of water under the bridge to prove themselves as pure solution. And then we'll see them adapted in a vast amount of scenario in production even. But yeah, as you say, at the moment, pretty much where we are.
Uh-oh.
So another thing I wanted to mention is effectively the monolithic versus microservices approach. So what you do when you did so far, when you dealt with anything that has to do with application, you've been essentially procuring 3 different servers, pretty much the same, and replicating effectively, as you can see, scaling. Yes, so I replayed the animation just to make it clear. And my application is made of 3 different pieces, as you can see through there, 3 different colors, and they're all basically cloning. So when one goes down, the other one comes up, and that's pretty much the way I've been doing availability or maintenance or continuity on my service. Now, with microservice, the approach is completely different. So now my app is made out of those same different parts, and now I have 2 applications to show you, but they're not forcefully tied together, either in the same box or the same binary package. They could be deployed differently. They listen to the network, so they could work as long as they are basically connected on the network. And what's happening now is what we're going to do is we're going to duplicate those services across a variety of also not 3, but maybe a lot more. They're in a cloud. They're not going to be falsely in a cluster. They're just going to be on the same network and ability to communicate together. And effectively now we're replicating to a point that there's always, as you can see, for example, the green part of the app, there's 1, 2, 3, 4 copies of it, 5 copies of it. So I know I'm going to have a certain redundancy. And then you're thinking, wow, that's great. So I can have better high availability, but it looks a lot more complex to manage. So effectively there is a part of complexity not into thinking, it's actually not more complex, it's a different way of thinking about it. So you're not going to think about the whole app and the whole standard and the whole tenure, you're going to think about that microservice. And now think about that microservice, what is it made of? Well, it is made of several containers behind it that are actually answering the request. And what is very interesting there is that those containers, as I mentioned before, are very quick to deploy. So I will be effectively able to replace a container service without any effect to the client, without any effect to anybody consuming the service. Or maybe a minor effect that just a quick refresh on the browser will fix. So it's very interesting of that because now I have with containers the ability to replace live services with new version very quickly, or even better through a worldwide application to decide on a specific zone or separation zone where I may want to test earlier version of the product or where I may want my DevOps team to actually do a lot more. And that will be maybe a market that is not so dynamic or not so demanding than others where you could allow yourself to do this. So containers give this, and I want to make sure that we understand how it works. So the way we work with Azure Container Service and Azure and Mesos and Docker, you have your same app running, and then you'll see you have, of course, 3 hosts, and those 3 hosts will have containers behind. And my 2 different applications are going to deploy very similarly, as we just described, across my variety of hosts in Azure. And then what's going to happen is I may have a failure. So if I have a failure, effectively suddenly that box, for example, doesn't work anymore, what's happening is that microservice will then migrate. And as you can see, the green one is already running somewhere. So I'm still going to be okay providing the service, and this will come from resilience and redundancy. And during this time, this container will be redeployed, and essentially the machine will be recycled or redeployed. But what you can see is very quickly I have a turnover of services and I'm not losing any part of the service at all.
And of course the fabric is doing that all for us automatically. And I think what I find interesting, that what you mentioned in your first slide, is that this isn't your father's Microsoft.
Yeah.
The guys in Azure said, hey, Mesos is the accepted, already proven standard for doing this. Why should we build a new one? Let's use that. So the Azure Container Service is built on top of Mesos. So people have got that extra confidence that it's battle tested and already out there in use.
Absolutely, and as well when it comes to standard, and most importantly, looking at hybrids too. So imagine if you had a whole Mesos or container implementation on site, and now you're going, right, I want to actually maybe counterbalance it somewhere. So you're completely right to insist on this. Our implementation, our Azure Container Service, is a straightforward DCOS implementation in Azure, and we're quite clear about it, of the different access that it gives you to manage it and etc. So it has been GA only for 3 weeks now, so I really recommend to have a look at it. But this is not only the feature, but I give you a battle-tested solution, something that is on standard and something that is on the Docker as well, container standard, which help you obviously to redistribute those Docker images elsewhere.
Yeah.
So all this brings us to really what we're trying to lead to from the start, which is DevOps and containers are actually very good together and a fantastic subject together. And why? Because in the past, when you've been developing an application, the first thing you do is to actually send it to the testing area, sending to the pre-testing, to the UAT area, etc. And you're moving that application across different environments. And what provokes their failure in most of the case is that difference in that environment. It's actually, you believe it or not, it's very hard to replicate exactly an environment side to side. Try it tomorrow, get a machine, buy it, deploy it, do something, and try to do the exact same. It won't be, unfortunately. I mean, despite all the effort and despite trying to make it a very exact science, it won't be. So effectively, now the idea, imagine if I take my application and if I put it within this ecosystem into my containers, right? And now I move the containers across. So my application never changed really environment. The libraries, the binaries, the data that you access are all within the containers. It's the containers that move. And this gives me a superb advantage of being able to do proper build and testing and offsetting the environment difference as a result for failure in test. And believe me, to anybody who's done development by moving pieces across, they go, wow, this is a major news. Of course, because that environment. So the way, if you look at that slide, the way it looks, so effectively the developers are running and building their application into their own containers. And remember that format is, the container format is a standard. So then they're going to push that container to a central repository. It could be any kind of, version code repository. It will be a binary object. It will be whichever it is, you're going to push it to the repository. And then, of course, operation and automation at night when the developer have left the house, they will effectively now take all those containers from the central repository, build them properly, launch them on the cloud platform, run unit tests, run product tests, do all this, close the app, and send back the result to the developer, right? So effectively, you come back in the morning, you go, wow, okay, now I know what the build last night. Oh, somebody committed that was wrong. Somebody committed that make the whole build fail. And effectively having that full traceability and history on the commits and who participate to the project is what is very important with DevOps. But more importantly there, operation and developer collaborate, obviously, for app metric, insight, and etc. And that's where ops, when they're going to actually push those containers and see the number of failure, the number of resilience, the CPU usage, all those kind of things, these are superb information that not a lot of people have currently, particularly on containers. So you used to have it in previous environment. It's important to assign to the container model. And then, of course, the developer update, iterate, and deploy updated container. Remember, like I say, it takes one command line and literally a few seconds to redeploy a new container on top of yours. So if a developer does that and sync is, oh, you were working on it and suddenly you receive an update, you say, oh, there's a brand new code, no problem, sync up. And just again, a few seconds and you will have downloaded the latest code, the latest update from the other container. So a very, very effectively interesting area. Here you can see, of course, when you have a bug or that gets fixed and all those get re-rolled. So when it comes to automated all of that, because of course we have great granularity, but maybe we gain some complexity. So it's very important to balance and to look at the automation. So this is just an example, and there's many different ways you could do it, but that's just basically something easy. So you will have a build system that will be the Jenkins, for example, whichever, and that will build and land whatever the result of that build is into a version control system. So very important that you're versioning absolutely everything. That's pure traceability. Not versioning is like erasing your backup. It's a very, very irresponsible move. And then from there, you look into continuous integration. So this will start to actually deploy, bring it to hosted, bring it to service that you define with the project. Then we'll potentially look at Docker. So once you have that, you'll potentially look at it and put it in a Docker container. And from that Docker container, obviously, it's coming back to build and interaction. So that's the just DevOps and container we just discussed. And then now we're going to continuous delivery. So from the integration and the test on the container, maybe there's a stage and there's a model where everybody agrees, there's a consensus across the flat DevOps team saying, hey, yep, it's time to publish, so it's time to have a look on the other part. And then from continuous delivery, then you can push it directly to Azure Container Service. So as you were mentioning, the beauty is that this full Docker API is fully open. It's exactly the same as running Mesosphere. There's absolutely nothing that changes there, so you'll be able to use the same tool if you used to, or just learn them, or even just use our interfaces, because we have a nice interface for it, and then directly push your containers there. And then you could have Azure could not only be your running environment, but it will be as well your testing environment for your different containers. The last part of that is if you're a CSP, service provider, ISV, if you provide a service around it, obviously, using those services, you could provide your app as a container to Azure, of course, and it will be listed into the category of containerized app. So again, don't look at it as just the development side. This is as well a GTM, a route to market, and this is as well a very potential way to make people try your application very quickly, just by having a couple of clicks within containers, within stuff that is, is not, how can I say, it doesn't condemn machine, it doesn't block you into any situation. It's very easy to browse and try, and that's really the aspect we're trying to put forward there.
And I think importantly, it reduces the time it takes us to go from a new feature request or a bug to deployment, and it increases our confidence. So the MD loves us, and we don't get kicked out of a job every time we mess up a deploy. That's a very good point. I think it's you're right that implementing DevOps properly will make a lot of people shine, particularly in the organization where they were not having that visibility. You're fully right, and I think really the acceleration of time to market and future build, that's where DevOps comes in. Yeah, I mean, company want to be performant. You realize there's only maybe 2 or 3% of top IT companies that are really in that performance case, and DevOps could be a major transformation enabling those advantages.
Conscious of time, and wanting to really mention it. So this is another slide. All platform or client, I think we're repeating really what we're trying to achieve there, and to make sure that everybody can consume the cloud and the Microsoft Cloud easily, without any kind of blockers in front of you. And again, this is not a slide, this is actually coming directly from a documentation center of Azure. So if you go to azure.microsoft.com and click on documentation, you'll land there. And then as you can see, it's written from the documentation itself: build any solution with any language, target any browser, client or device, run Windows or Linux. Here you can see a very quick vision of the little SDKs that we made available. So we'll be from Node to mobile to media to Ruby, PHP, .NET, whichever you like. And then of course mentioning the GitHub repository, so github.com/Azure, github.com/Microsoft. The first one I mentioned is github.com/Azure. This is 100% open source, and this will be available for you to browse, contribute, download, do whatever. And github.com/Microsoft, that will be not guaranteed open source, but definitely contributed from the Microsoft employees. So have a browse, have a look, have a comment. They're always welcome there. Okay. And note as well, another quick note, is that our documentation is as well editable through GitHub. So if you find an issue in documentation you like to point, you just right click and say, hey, edit on GitHub. You've cloned it into your GitHub, you put your commit, you commit it back. If it gets accepted, your lovely little face will appear into the contribution page of the documentation. So no, I mean, that's a way to show the community and take as well into what we're doing.
Yeah. Okay, well, thanks very much, Boris. That's been a really good session.
Thank you.
We're going to take a short break now, and then after that, I'm really excited to be talking to Brian Harry about the direction that the Visual Studio team are taking around DevOps. Thanks very much.
Reflecting effectively that advance, reflecting that openness, that change, that new Microsoft effectively kicking in. So this is important to understand the strategy. But now let me show you, I mean, I'm sure you follow this, but let me show you a few of the announcements that we made recently. And I know people are very, very surprised looking at it. So the first thing is, of course, SQL Server. We have announced that SQL Server will be effectively migrated and ported running on Linux host in Azure. And this will be done around mid-2017. We have a very active project for it. There's a page that you may welcome to look at, microsoft.com/SQL on Linux, in a single word lowercase, that will redirect you to the right page. And on this, you can effectively connect to actually request some news and some information, but you could as well just request to be potentially added to the preview. So I don't want people to get excited over the video, and I'm going to tell you the reality. The day we launch SQL on Linux, we receive more than 9,000 requests within the next 2 hours to be part, obviously, of the preview. So you can imagine this is already filling our case of preview currently. So unfortunately, I can't promise anything for preview right now, but at least you'll be able to register your email and receive update notification on other project advance. Red Hat, very important one. So Red Hat Enterprise Linux was not a certified operating system on Azure. It is now. It is now since November. And effectively what we've been doing is having not only just an agreement with Red Hat to certify, but as well a much broader announcement of various different interactions. So essentially we're going to have .NET support lead behind our Azure Compute Service, Azure Container Service. So very interesting. You can see all kind of data and stats there. 60% of our marketplace are based on Linux, so people who will deploy a solution from the marketplace will deploy Linux pretty much without knowing it. And 1 out of 3 VM now, I can reveal, is effectively now on Azure running Linux. So this is quite extraordinary in a race. We're very excited to see this, and I think it's important to see that there is a demand and that the customer are very happy to look at it. So I think this you've seen several times, and I think we discussed that slide several times. I'm sure it's absolutely not new for anybody out there. But I want to repeat really that idea that not only we're enabling technology, but we're making them come first from an area that we call ecosystem provided, you see on the right there. And that area will be an area where we'll have community support images, where we'll have community vendors who will support the image, but Microsoft itself won't endorse it from a support point of view. We let you run it. We just make sure we validate it and make sure that it works, but we won't provide direct support on it. We rely on the community. But what's interesting is as we built our ecosystem, as we're getting closer to the people across there, we effectively then move them to integrated, where our own support can relay the calls there. And you can see this obviously. So for example, that slide shows you Xamarin, which we have made an acquisition of. Yeah. And obviously now Xamarin is completely to the left inside of the slide.
And I noticed just this morning in my blog feed that Jenkins now has got a much closer
Bolted on top of Red Hat Enterprise Linux for customers wanting to, again, mix the different technology across. We're going to support their PaaS platform, and at the same time, of course, Red Hat supports all of the product of Microsoft on site. So it's a nice exchange and nice collaboration there. HD Insights, so as you know, this was our Hadoop on-demand platform that we had on Azure. This was exclusively running on Windows. So we have now made it available on Linux hosts. So by default, when you go and provision your PaaS in your Azure interface, you can say, hey, give me HD Insight, but actually I want it on top of Linux host instead of Windows host. And this has been available. And what's interesting is a lot of people dealing with Hadoop on demand are data scientists who are very interested to have a low-level access to the shell and be able to manipulate their data. So as a result, not really because it's on Linux, but as a result of the accessibility, we've seen really a very big hike in the consumption of HD Insight. Eclipse, we joined the Eclipse Foundation. So Eclipse obviously is one of the biggest IDE for the Java world, but it does other languages than Java too. But we have now launched the foundation, which means Windows and Microsoft are an active part of it. And obviously .NET will be added to the list of language supporting Eclipse. So the idea there again is to enable a developer to be able to deal with different language, different technology from the same single host. The Windows subsystem for Linux, I think this is the newest announcement. That's the one.
It's certainly the one that's got me most excited. I spent a lot of time playing that.
Have you?
Days, it's really great.
It's interesting. My machine is running it as well. And I think what's interesting there is effectively to enable suddenly a little bit of Linux tooling, a little bit of command line to be able to do various things right and left. So this has been a...
Welcome back to Tech Days Online, the DevOps Day. With me, I'm very pleased to introduce the only man that talks faster than Andrew Fryer. This is Boris Devouche, newly employed at Microsoft, Mr. Open Source, and he's going to talk to us for the next 45 minutes about open source and DevOps. Boris, over to you.
Thank you very much. So thank you very much, everyone, for joining today. And today, effectively, an interesting subject, a subject that we're not used to see within Microsoft. Open source on Azure, and particularly implementing DevOps process and methodology on Azure. So how does that look like? The first thing to understand is effectively is how Microsoft open source momentum is currently alive. So we have made various announcements, and Microsoft has opened us enormously to go effectively across the other side and allow customers not only to run the well-known and trusted Microsoft technology in Azure, but as well to run anything that is coming in terms of innovation, open source, other framework, and effectively making sure those can interact across solutions, particularly when people are going to the cloud and trying to export effectively infrastructure outside of the company. So that open source momentum you can see on that slide is reflected by various announcements with OpenSource.net. Satya came obviously out there and spoke to the people and say, hey, we love Linux. Actually, what he was doing is revealing to the world that about back in the day, 20% of every single VM in Azure worldwide were powered by Linux. So it was a very interesting statement from Satya to come out with this. Then you can see some various quotes, obviously, from the press requests coming mainly from the developer community saying, hey, I use Sigwin, I use Putty, I use those tools that are not falsely endorsed. It'd be nice to have something endorsed. So we have done that, and you can see on that slide a little bit of a demo there. So essentially, you just launch your command line interface on Windows, you type bash, you type enter, and this, well, I mean, no, that has been really ameliorated there. This is way faster. It will obviously do a little bit of install for you. You need a build of Windows 10 that is higher than 1314 in order to get effectively this. But this is a new, what we call the Windows subsystem for Linux, which is available and get you a full Linux shell available in Windows, so enabling you to effectively interact with the other part. So a lot more announcements have been made. So another thing interesting that I wanted to say today is that we have now a certification for Azure, for Linux on Azure. So how does that work? That's a mixed certification essentially between the Azure Foundation and a certification course that has been put by partnership by the Linux Foundation. So once you pass the two elements, then you become officially Linux certified on Azure. So very interesting. Our Microsoft employees, so Vim has joined us from Oracle. So Vim is actually Mr. Linux Oracle, been working there for 20 years and more responsible of the major change of Oracle towards open source software. So is in Corp and will be essentially heading or head of full vision into Linux. And Ross Gardler, obviously, which maybe you heard of, is a Brit, but he lives in the UK now, in the America now. And Ross is actually president of the Apache Software Foundation, and accessory as well is